In this session, we shall concentrate on finding the convolution sum between exponential to exponential signals, those who are of infinite duration. So let us consider the first example where h of n is equal to alpha raised to mod n and x of n is equal to beta raised to n u of n minus 2. So as you know, first we should sketch a signal xn and hn. Now the sketch of alpha raised to mod n and beta raised to n u of n minus 2. The beta raised to n minus 2 will exist from n is equal to 2 onwards up to infinity with amplitude beta raised to n. So I've considered here beta which is greater than 1, so it is growing exponential here. And in a similar way, alpha raised to mod n, where meaning of alpha raised to mod n is h of n is equal to alpha raised to minus n when n is negative and is alpha raised to plus n when n is positive. So the sketch of alpha raised to mod n will be somewhat like this. So again alpha is greater than 1. That is what we assume here. So in both ways these are growing exponentials alpha and beta towards the infinity. Now this h of n exists from minus infinity to plus infinity and xn exists from 2 to infinity. So what is the left end of yn and what is the right end of yn? So the left end is the left end of hn is minus infinity and that of xn is 2. So yn is minus infinity and right end is infinity. Okay. So next we shall designate this x of n as xk and sketch it with respect to k instead of with respect to n, and hn will reflect about origin and redesignate it as h of minus k, and sketch both this xk and this h of minus k. Observe here that h of minus k is symmetrical about the origin, therefore even if you reflect its k will not different and it remains same, that is for k which is less than 0 amplitude is alpha raised to minus k, and for k which is greater than 0 it is alpha raised to k. Now once we have h of minus k and xk, we have to proceed ahead with the convolution, as this convolution exists from minus infinity to plus infinity. For n which is less than 0, we have to go on shifting this h of minus k towards the left side, and for n is equal to 0, you observe that we multiply xk with h of minus k. Now when we multiply xk with h of minus k, you observe here that the two xk and h of minus k, they overlap to each other from 2 to infinity, and therefore the product exists from k is equal to 2 to infinity. Therefore yn is equal to summation k from 2 to infinity xk into h of n minus k. Now to obtain yn for n which is less than or equal to 0, we have to go on shifting this h of minus k towards the left side. So when I go on shifting this h of minus k towards the left, you observe that always this is infinite duration sequence h of minus k towards this k which is positive towards this end, as well as it is infinite duration to this end. So if I go on moving this h of minus k to right side, every time for every value of n, you observe that these two x of k and h of n minus k, they overlap to each other from 2 to infinity, and the product always exists from 2 to infinity, and you observe that the amplitude of xk is beta raised to k and that of h of n minus k is alpha raised to n minus k. So h of minus k is alpha raised to k, so h of n minus k is alpha raised to n minus k. Therefore if xk is beta raised to k and h of n minus k is alpha raised to n minus k, then the convolution yn will be equal to summation k from 2 to infinity beta raised to k alpha raised to n minus k. This is for what? This is we are shifting left. This is for k which is less than or equal to 0. For n which is greater than 0, we have to shift right this h of minus k towards this side, and if you go on shifting right, this possibility of remaining with this amplitude alpha raised to k is only possible up to when you get this 0 at 2. That is another 2 times if you shift h of 2 minus k, still the amplitude of this h of n minus k will be alpha raised to n minus k. After that, there will be 2 amplitudes. So we shall concentrate it later on. Right now, let us evaluate this summation expression, where summation k from 2 to infinity beta raised to k alpha raised to n minus k. How to evaluate? What is the evaluation of this expression? So take common outside of this summation variation alpha raised to n, which is not a variable of k, and you'll remain with alpha raised to minus k here, and this beta raised to k into alpha raised to minus k shall be written as beta by alpha. So this summation k from 2 to infinity, it is beta by alpha raised to k. And therefore yn is equal to alpha raised to n beta by alpha square divided by 1 minus beta by alpha is the closed form of expression of this. This is the lower limit and the upper limit is infinity. So this is beta by alpha raised to 2. And then it is equal to alpha, if I take common from here, 1 by alpha outside. So alpha, if you multiply here with inside to this bracket by alpha and numerator by alpha, you will get here this as alpha raised to n minus 1 beta square upon alpha minus beta. So see, just a minute, what we will get here. So just I will take back. So when I take common here 1 by alpha, it goes and you will get here alpha raised to, sorry here, so we will get here alpha raised to n plus 1, and then afterwards here alpha square, and you will remain with alpha raised to n minus 1. So this is right. Okay, got this? How it is? This beta square and this 1 by alpha square, and from here 1 by alpha. So here you will get alpha raised to n minus 1 beta square upon alpha minus beta. This is for n which is less than or equal to 2. Now you will observe that even for n is equal to 2, still the product remains same. It is from 2 to infinity and alpha raised to 2 minus k. So this was up to n which is less than or equal to 2. Up to that the product will be same, and that we have got it is alpha raised to n minus 1 beta square by alpha minus beta. Now onwards, even by one moment if I shift, what will happen? You see here. That is for n greater than 2. If I shift by one moment towards the right side, what will happen? This is by shift. So what is your observation here? You observe that the amplitude of this h of n minus k up to minus infinity to 2, it is alpha raised to minus 3 minus k, and then from 3 onwards it is alpha raised to 3 minus k. Similarly, if one more times if I shift, that is for h of 4 minus k, you will observe that the amplitude of this h of 4 minus k is alpha raised to minus 4 minus k up to 3, and then for 4 onwards it is alpha raised to 4 minus k. So in general, for n is greater than 2, for h of n minus k will have two amplitudes, that is from k is equal to minus infinity to n minus 1, it is alpha raised to minus n minus k, and then from n onwards it is alpha raised to n minus k, and the product if you take, it will always remain from 2 to infinity. And in that product, the product will be, in that product, the h of n minus k will have two amplitudes. This from 2 to n minus 1, h of n minus k is alpha raised to minus n minus k. And then from n to infinity, h of n minus k is alpha raised to n minus k. And the product still exists from 2 to infinity. That is what we have observed. So this writing summation summation for obtaining yn at nth instant, this k varying from 2 to infinity still x of k into h of n minus k, and this xk into h of n minus k, xk is beta raised to k for the entire duration from 2 to infinity, whereas h of n minus k has two amplitudes, that is from 2 to n its amplitude is alpha raised to minus n minus k, and then from n to 2 to n minus 1 it is alpha raised to minus n minus k, and then from n to infinity it is alpha raised to n minus k. Therefore, dividing this entire summation into two parts, that is summation k from 2 to n minus 1 beta raised to k alpha raised to minus n minus k plus k varying from n to infinity beta raised to k alpha raised to n minus k. So let us evaluate each of these summations separately. So first let us evaluate this summation expression and write its closed form of expression. So the closed form of expression for this, where summation k from 2 to n minus 1 beta raised to k alpha raised to minus n minus k, we shall take outside alpha raised to minus n from it. So remaining is summation k from 2 to n minus 1 beta raised to k alpha raised to k. So beta alpha raised to k you get. So that closed form expression you can write it as alpha raised to minus n alpha beta square minus alpha beta raised to n upon 1 minus alpha beta. And then let us evaluate the second part of the convolution sum, that is summation k from n to infinity beta raised to k alpha raised to n minus k, where alpha raised to n I take outside. So inside the summation you will remain with beta raised to k alpha raised to minus k, and this beta raised to k alpha raised to minus k shall be written as beta by alpha raised to k, and the closed form of expression is alpha raised to n beta by alpha raised to n upon 1 minus beta by alpha. Now multiplying with this, this is alpha raised to n, you will get here beta raised to n and another alpha to both numerator and denominator. You will get in the denominator alpha minus beta, so and in the numerator alpha into beta raised to n. So yn is equal to alpha raised to minus n alpha beta square minus alpha beta raised to n upon 1 minus alpha beta plus alpha beta raised to n upon alpha minus beta, and multiplying inside with this alpha raised to minus n to this numerator and further solve this, you will get yn is equal to alpha raised to minus n plus 2 beta square minus beta raised to n upon 1 minus alpha beta plus alpha beta raised to n upon alpha minus beta. This yn we obtained it for n which is greater than 2, and therefore summarizing this y of n for n which is less than or equal to 2, yn is alpha raised to n minus 1 beta square upon alpha minus beta, and for n which is greater than 2 it is alpha raised to minus n plus 2 beta square minus beta raised to n upon 1 minus alpha beta plus alpha beta raised to n upon alpha minus beta. Now this is the second example where in the figure you observe that there are two systems which are connected in cascade to each other, and we are supposed to find out the overall sample response of the system. So overall sample response Hn of the system, corresponding overall system, is the convolution of this impulse responses of these two systems. That is, Hn is equal to h1 of n convolved with h2 of n. So this is another problem of a convolution. Given that h1 of n is 1 by 2 raised to n un and h2 of n is 1 by 4 raised to n un, so both are infinite duration exponential signals. So let us sketch h1n and h2n. So h1n is half raised to n, un's meaning is it is existing from 0 to infinity, and h2 of n from 0 to infinity with amplitude 1 by 4 raised to n. So this convolution sum expression, which is summation k from minus infinity to plus infinity h1k into h2 of n minus k to evaluate, we have to sketch this h1 and h2 with respect to k and reflect h2 with respect about the origin and redesignate it as h2 of minus k and resketch. So before moving ahead with, the left end of this hn is 0 and the right end is infinity. Now this is h2 of minus k and this is h1 of k. For n which is less than 0, we need to shift this h2 of minus k to the left side, and you observe that there will be no overlapping between h1 of k and h2 of n minus k. Therefore, h of n will be equal to 0 for n which is less than 0. Now for n which is greater than or equal to 0, you will observe that we will be going on shifting this h2 of minus k towards the right side. And every time if you go on shifting this to the right side, you will observe that this h1 of k and this h2 of n minus k, they overlap to each other from the duration of 0 to the value of n, by which if you have shifted h2 towards the right side. Up to that, these two overlap and the product will exist from 0 to n. So k will be varying from 0 to n, and therefore this convolution sum expression becomes summation k from 0 to n 1 by 2 raised to k and 1 by 4 raised to n minus k. Now this 1 by 4 raised to n minus k, we take outside here from 1 by 4 raised to n of this summation variation, and you remain with k varying from 0 to n, half raised to k, 1 by 4 raised to minus k. 1 by 4 raised to minus k shall be written as 4 raised to k, and then 4 raised to k and this 1 by 2 raised to k, you will remain with 2 raised to k here. And the closed form of expression of 2 raised to k is 1 minus 2 raised to n plus 1 upon 1 minus 2. And this I will rewrite this as, this becomes minus 1 in the denominator. So this numerator I will write it as 2 raised to n plus 1 minus 1. So the overall hn is 1 by 4 raised to n, 2 raised to n plus 1 minus 1. This is for n which is greater than or equal to 0. So if you multiply inside to this 2 raised to n plus 1 upon, in the denominator you have 4 raised to n. 4 is 2 into 2. So it is 2 raised to n into 2 raised to n. So 2 raised to n and 2 raised to n will get cancelled. So it will remain with 1 by 2 raised to n minus 1 minus 1 by 4 raised to n. This is for n which is greater than or equal to 0. Therefore, we multiply this with un to designate it as that it is exists for n from 0 to infinity. This is your all in samples response hn. So thank you very much students for your patience hearing.